Alright, so after filtration has occurred, the next step is reabsorption. In the glomerulus, the components of the blood that are filtered out into the Bowman's capsule, it's always based on size. So if something is small, it will be filtered out of the glomerulus. If something's big, it will stay inside of the blood. So what happens if something's small and it's something that the body wants? Well, that's where reabsorption comes in. So the second step in the excretory system in the process of osmoregulation and excretion is getting back the things that the body lost that it still wants. Um, so there's a number of different places where reabsorption occurs, and in the different locations you're going to see different components being reabsorbed. So this is just taking another look at the nephron. We've got filtration happening up here in the glomerular capsule and the glomerulus. Okay, so the filtrate comes out into the Bowman's capsule. The next step is you've got something called the proximal convoluted tubule. This is this bendy part here. And so proximal because it's close, or it's the closest part of the nephron to the glomerulus. Convoluted because it's twisty. Okay. Then you've got down here something called the loop of Henle. And you've got on this side the descending loop of Henle, and then on the other side you have the ascending loop of Henle. Okay. One's going down, one's going up. Over here you've got the distal convoluted tubule because, again, it's a tubule that's twisted, but now it's further away from the glomerulus. Eventually the nephron drains right here into the collecting duct, and it will move on its way to the renal pelvis. So now that we've got the different structures of the nephron down, let's see what's being reabsorbed here. So this is a diagram where the lighter of yellow color signifies that you have a lot of water, okay, and very little solute. The darker the yellow in color means the higher the solute concentration and the lower the water concentration. So in the glomerulus, after the fluid is forced out, water obviously being a small molecule, much of the water is put into the filtrate. So the solute concentration right here at the beginning of the filtration or at the end of the filtration process is really made up of a lot of water. What's going to happen is that you move through the proximal convoluted tubule and into the descending loop of Henle, and as you go into this descending loop, what you can see is that the concentration of solute is increasing. What's causing that increase is that water is being reabsorbed by the blood vessels that are surrounding the descending loop. So water is going from the filtrate back into the blood. It's being reabsorbed in the descending loop. Over on the other side, you're going to see that the dark yellow color again starts to become lighter. And the reason for this is that solutes are going to be pulled across in the ascending loop of Henle. And so what you're going to see here is that things like sodium and chloride are moving into the blood. They're being reabsorbed. Okay, we want to have those two things. As you're moving up here to the distal convoluted tubule and the collecting duct, you can notice that in the beginning it's a very light yellow color and it gradually begins to darken. And this is because, again, you're going to have water being pulled out of the filtrate and being reabsorbed. So because water is a small molecule, it's able to go through the glomerulus here, and you need to reabsorb it. It's going to be reabsorbed primarily in two places, in the descending loop of Henle and in the collecting duct. Now, water, if you go all the way back to cells, you cannot have active transportation of water. You can only have osmosis. And if you go back to um, cells, remember that you could have active transport of sodium. Remember the sodium-potassium pump. So some ions can be actively transported. So what's happening here in the loop of Henle, in the ascending and descending loops of Henle, is that you're going to use active transport to increase the concentration of blood on the blood vessel on this side. Okay, so ions are being pulled across to intentionally increase the solute concentration of the blood. What happens is, as the blood vessel starts to go in this direction, okay, running anti-parallel to the descending loop of Henle's, you can see that the solute concentration is really high. So because of osmosis, the water wants to go in and equalize those solute concentrations. So as a result, when the blood is leaving the loop of Henle, it's collected all the ions and water that it needed to reabsorb. So it's kind of an ingenious way here for the body to get water back into the blood without being able to directly actively transport it. Okay, so we're going to use the active transport of the ions to increase the solute concentration. That's going to cause the water to want to be pulled across. The blood exits, got its water back, got its salt back.